So this is a sparsity, and the sparsity will be defined. We're gonna practically look at the probability of it, and so we're gonna have the messages underscore bow dot number of non-zero messages divided by the sum, not the sum, but the product of the message bow, message dot shape. We're gonna graph the first entry. So in our matrix that we created, the matrix is going to have 5,572 different columns, and it's going to have 11,444 rows. So we want to multiply them because that's going to be how many entries we have on that matrix. And then we're going to print the sparsity. We're going to put a percentage there just to make it a little bit. I don't like this one. I like this one more. F string format. And oh, I forgot also to do multiply this by 100. Why is this complaining tuple? Oh, I used parentheses instead of brackets. Oops. We're looking at the access the first entry, and we're going to access the second entry there. So sorry, I used the parentheses instead of brackets. There you go. So this is saying that the probability of the number of non-zero words, it's so low. It's like 0.07%. That's pretty low. After counting the term weighting and normalization can be done with the term frequency and the inverse document frequency. So we're gonna look a little bit more into different ways of calculating, other ways of looking at the patterns, the frequencies, and the weight value of each word. So as you can see here, we did some analysis, but we can look at a little more in depth with what they call the term frequency and the inverse document frequency. So we're gonna look at that. We talked about this a little bit in the PowerPoint, but let's talk about it again. So the term frequency, inverse document frequency, is practically it is the weight value. It's a value which is often used in the information retrieval and text mining. So we use this to be able to find out the frequencies of certain words in comparison to the whole documents. This weight is a statistical measure used to evaluate how important a word is to the document in a collection of corpus. So this is, like I said, looking at the whole picture. One word, a comparison into the whole picture. The importance increases proportionally to the number of times a word appears in the document, but is offset by the frequency of the word in the corpus. Variations of the term frequency, inverse document frequency, weighting scheme are often used by search engines as a central tool in scoring and ranking the document's relevance given the user query. One of the simplest ranking functions is computed by summing the the term frequency, inverse document frequency for each query term. Many of those sophisticated ranking functions are variants of this simple model. Typically, the term frequency, inverse document frequency weight is composed of two terms. The first computes the normalized term frequency. So that's just practically counting how many times did the word appear in the message. The number of times the word appears in the document. So what I just said, right? Divided by the total number of words in the document. So the second term is the inverse document frequency, which is computed as the logarithmic of the number of the documents in the corpus divided by the number of documents where the specific term appears. So I'll talk about it more specifically in the bottom part. So again, the term frequency, which measures how frequently a term occurs in the document. Since every document is different in length, it is possible that the term would appear much more times in long documents than in shorter ones. That makes sense, right? If you have a longer document, the more likely a term will appear more frequent. Thus, the term frequency is often divided by the document length. So we're gonna take the number of times a word appear, the frequency, right, divided by the total number of terms you have on the document. So that's practically how you measure the term frequency, the number of times term that appears in the document divided by the total number of terms in the document. Very simple, very straightforward. The inverse document frequency, which measures how important a term is. While computing the term frequency, all terms are considerably equally important. However, it is known that certain terms such as is, of, and that may appear a lot of times but have little importance. Thus, we need to weight down the frequent terms while scale up the rare ones by computing the following. And so this is the inverse document frequency. This is how we calculate it. We take the log of the total number of documents, so that's how many documents we have in our case, the number of messages, divided by the number of documents with the term T in it. So we practically look at how many documents actually have this word, and that's going to determine the weight value. How much does this word is important to the entire document, right? So that's practically what this is doing. Consider a document containing 100 words wherein the word cat appears 3 times. So in order to find the IDF, the inverse document frequency, the term frequency in this case would be 3 out of 100. So that's the frequency, no problem. Now assume that there's 10 million documents and the word cat appears in 1,000 of these documents. So now it's different, right? This is the frequency. We can calculate the frequency because 3 out of 100, the word appears 3 times in a document that has 100 words. But for the inverse document frequency, we are saying that there's 10 million documents, and 1,000 of these documents contain that word cat. The way we figure out the inverse document frequency will be to take the log of 10 million divided by 1,000, which is going to give us a value of 4. So the weight is the product of these quantifiers. 0.3, the frequency times your log of the number of documents that you have divided by the number of times it appears. So this is going to give you the weight value. It's going to be 0.2. So let's go ahead and see how we can do this in a sklearn. So in order to be able to do this, we need to be able to import sklearn.feature extraction. And we're going to look at the text. That's where we're going to import it from. TFID transformer. And we're going to do also TFIDF transformer. Sorry, no I. Let's just take away this I right here. TF, the term frequency inverse document frequency transformer. And what we're going to fit the data with our message bow. And oops. Now what we're gonna do is we're gonna use our transformer that we just created, TFIDF transformer, and we're gonna transform our bow4, which is our message, the fourth message, just so that we can see what we get. We're testing it right now so you guys can see. And then we're gonna print our TFIDF4. So this is just specifically for, we're practically figuring out the weight value for our message, for our message word, for our message number 4 for each word. Remember we said that there's 4 words in the message. In the message 4 we have 7 words that appear that are unique, right? After we remove the punctuation and everything, we usually left with 7 words. And so we're doing it for each word here. We're calculating the weight value there for each one. So we have done this automatically, right? So you can see it here, just like the way we did it for the word cat. If it appears at that 3 times in 100 in one document, it has 100 words. And what did it do here? Oh. Okay, so anyways, so this is calculating the term frequency index document frequency, which is the weight value of that word to the entire document. Okay, and what we want to do here is we want to print. Let's print. We'll go ahead and check what is the inverse document frequency of the word "u" and the word university. So if we do a print, we're going to print that value. So we're going to do the TFIDF underscore transformer IDF underscore the bow transformer dot vocabulary underscore u. And let's do the same thing with the word university. Oops, I forgot to run the code right there. Oops. Let me see what's wrong with this. Yes, so I actually was doing it on the wrong message, right? We don't want to do it on message. We want to do it on messages underscore bow, because that's what we have actually trained. Now we can see that works there. And now we can actually check what is the weight value of each of these words, U and university, within the transformer data. Let's now transform the entire bag of words of corpus into the term frequency. So we're going to do messages underscore TFIDF equal underscore Okay, so now we're doing it to the entire messages that we turn into that we use the vectorizer, and we're looking at the dimensions. All right. There are many ways the data can be pre-processed and vectorized. The steps involve feature engineering and building a pipeline. I encourage you that you check the sklearn documentation to deal with this text data, as well as expanded collections of available papers and books in the general topic of NLP. Okay. So training models. Let me pause this. Let me make it go to the next video.